Good morning, students. We completed first unit till now, air refrigeration systems and cycles. Second unit is vapor compression refrigeration system. It is the VCR system, which is short form is VCR system. This VCR system is an improved type of air refrigeration system in which the working fluid called refrigerant is used other than air. Yet the commonly used refrigerants are ammonia, carbon dioxide, sulfur dioxide. These are the inorganic compounds, and also chlorofluorocarbons we can use in this vapor compression refrigeration system. What is the main difference between the air refrigeration system and vapor compression refrigeration system? A difference between the vapor and the air refrigeration system is that the working fluid is changes, and also in place of turbine, the turbine is required to expand the air in the air refrigeration system. In place of turbine, the turbine is replaced by a small expansion valve in the VCR system. Expansion valve is used to reduce the pressure of the refrigerant from compressor pressure to the high pressure to low pressure. Okay, that turbine, say the expansion valve done same function as that of the turbine in air refrigeration system. Okay. Let us go for the introduction for the air refrigeration system, vapor compression refrigeration system. A vapor compression refrigeration system is an improved type of air refrigeration system in which the suitable working substance termed as refrigerant is used. It condenses and evaporates at temperatures and pressures close to the atmospheric conditions. Continuously, the working fluid is condenses and evaporates at some temperatures which are closer to the atmospheric pressure. The refrigerants usually used for this purpose are ammonia, carbon dioxide, sulfur dioxide, etc. The refrigerant used in this system does not leave the system. This is the main difference. In open air refrigeration system, air is continuously replaced, but in this system, the working fluid does not leave the system. That is, the working fluid is continuously recycled within the system. In this VCR system, the working substance changes its phase alternatively from liquid phase to vapor and vice versa. Continuously, the phase changes occurs in the system. Therefore, this system is also called phase change system, or this cycle is called phase change cycle. Whenever the working fluid changes its phase, it absorbs the latent heat along with the sensible heat. The air refrigeration, in the air refrigeration system, air only absorbs the sensible heat because the air is always in the gaseous state in the system. Okay. What are the merits, the advantages of VCR system? Nowadays, we are using almost all the system, all the components, we are using VCR system. We are using this VCR system in cold storages, room air conditioners, domestic refrigerators. In every system, we are using VCR cycle. That every system works on VCR cycle. Okay. The advantages are VCR system having compacting nature. Compact means smaller in size for a given capacity. To produce 1 ton of refrigeration, per ton of refrigeration, the size of the VCR system very small when compared to the air refrigeration system, because air refrigeration system having a bigger size of compressor and turbines are needed, because that's why it occupies a more space when compared to the VCR system. Clear? And a less running cost. It has a less running cost. VCR system has less running cost when compared to the air refrigeration system per ton of refrigeration, and it can employ over a large range of temperatures. What it means, the VCR system working between a large range of temperature. That is, condenser and evaporated temperature difference is very large. Even that condition, VCR system can work. Okay. There is a limitation in this case for the air refrigeration system, because air refrigeration system works between not work between the very large temperature difference. Because the low temperature is at below atmosphere temperature, smaller, close to the atmosphere temperature at pressure, and also the high pressure, that is the sink temperature, is also nearer to the atmospheric temperature. That's why it is operating between a narrow range of temperatures. But VCR system can operate even if you maintain the large range of temperature. Clear? Then its COP is quite high. This is the main advantage of VCR system. That's why we are using nowadays the VCR system, because of COP is very high. COP means the refrigeration effect by work input. That is, when compared to the work supplied, the refrigeration effect will be produced by this VCR system is very high when compared to the air refrigeration system. Okay. For air refrigeration system, almost is near to 1 or less than 1. We are already seen in the earlier unit. But COP of VCR system is always greater than 1. Clear? These are the 4 advantages when compared to the air refrigeration system. Then demerits also there for the VCR system. The initial cost is high. Initially, the VCR system uses compressor, condenser coils, copper condenser coils. Okay, these are the very high cost when compared to the air refrigeration system, because air refrigeration system having built-in compressor in the aircrafts. We need not purchase separate air compressor. Okay, VCR system is initial cost is high. The prevention of leakage of refrigerant is the major problem, because we are using the harmful gases, harmful refrigerants we are using in the VCR system. But air refrigeration system, the working fluid is air itself. Air is no harmful to the human being, and also does not affect on the nature. But refrigerants which are going to use in VCR system are drastically changes the nature condition, and also which are very harmful to the human beings. That's why the prevention is the very, very important. Prevention of leakage of refrigerant is very important in VCR system. Okay, this is the major problem, which is the under demerits. These are the merits and demerits of VCR system. Let us go for the mechanism of VCR system. What are the components involved in the VCR system and how they works? In this class, I will discuss the mechanism of VCR system. As we know that the simple VCR system consists of the following essential 5 components. These are the 5 essential components for the simple VCR system. This is the simple VCR system, which consists of compressor. It is the heart for the VCR system. It is just like heart. And condenser, receiver. Condenser is the copper coil. Receiver is the storage device. Expansion valve, it is a throttle. What is also called a throttle valve, which will be reduce the pressure. And our last one is evaporator, at which the refrigeration effect is produced. This evaporator is also a coil of copper pipe. Clear? Look at this diagram. First of all, this is a schematic diagram of VCR system. This is the reciprocating compressor, refrigerant compressor, in which the compressed air, compressed refrigerant will be sent to the condenser first. After compressing, the condition of refrigerant is high pressure vapor. That high pressure vapor will be sent to the condenser coil, which is a copper coil, in which the working fluid, cooling media, on which the cooling media is air or water can be used for cooling purpose. And after the vapor will be sent to the condenser, first few coils, it will be cooled, temperature decreases and converted into the dry saturated vapor. Then some of the coils, in some of the coils of condenser, it will be converted into liquid by rejecting its latent heat. This is the high pressure liquid vapor mixture. This liquid vapor mixture will be received in the receiver, that is stored in the receiver, in which the liquid only will be taken into the expansion valve. Expansion valve or refrigerant control valve, which is also called throttle valve. This is high pressure liquid will send to the expansion valve. From the expansion valve, we will get the low pressure liquid vapor mixture. During the flowing of expansion valve, flowing of liquid through the expansion valve, due to the friction between liquid and expansion valve, some of the liquid refrigerant will be vaporizes, and coming the condition of the refrigerant at the outlet or the exit of the expansion valve is liquid vapor mixture. But we required only liquid. The liquid only absorb the heat in the evaporator. That liquid vapor mixture will be sent to the evaporator coil, which is also a coil of copper pipe, okay, which is located in the insulated chamber because it is maintained at lower temperature. This vapor liquid mixture will be sent to the low temperature pressure vapor mixture is sent to the evaporator, at which the heat is absorbed from the required space. By absorbing the heat, the liquid vapor mixture completely vaporizes by absorbing the latent heat. That vaporized liquid refrigerant, low pressure vaporized vapor refrigerant will be sent to the compressor again, in which the vapor refrigerant again compressed to maintain the high pressure. This is the low pressure side, pressure gauge to measure the pressure on low pressure side. This is the pressure gauge, which measures the pressure on the high pressure side. This is the high pressure side up to this, and this is the low pressure side. The expansion valve will decrease the pressure. Compressor increases the pressure. The condenser operates at higher pressure. Now evaporator operates at lower pressure. Clear? This is the total essential 5 components here: compressor, condenser, receiver, expansion valve, and evaporator. Clear? Here the working fluid, that is the refrigerant which is flowing into the cycle, changes phase from liquid to vapor in the evaporator, again the vapor to liquid in the condenser. Like that, you have to the working fluid is changes. Working fluid changes from liquid to vapor to liquid continuously. That's why this cycle is called phase change cycle. Okay, it is very compact in nature when compared to the air refrigeration system. These are the components. Compressor. What is the function of compressor? We know that the low temperature and pressure vapor refrigerant. The refrigerant state before the compressor is vapor refrigerant. When the vapor refrigerant compressed by the compressor, it is called the dry compression. Otherwise, whenever the liquid particles is there before compression process, that compression process is called wet compression. The wet compression is very harmful to the compressor, because due to the wetness of the refrigerant, the compressor will be damaged due to erosion and corrosion. Okay, the vapor refrigerant coming from the evaporator will be compressed in the compressor. Evaporator is drawn into the compressor through the inlet valve, where it is compressed to a high pressure and temperature. The high pressure and temperature vapor refrigerant is discharged into the condenser through the delivery valve. It has 2 valves. Compressor has 2 valves. One is an inlet valve, which is located as A here, inlet valve, and delivery valve is B. From the delivery valve, the high pressure vapor refrigerant will be delivered to the condenser. Then condenser function is, the condenser consists of coil of pipe, only coil of pipe, in which the high pressure and temperature vapor refrigerant is cooled and condensed. Cooling means dropping temperature. Condensed means in constant temperature phase change occurs. Cooled and condensed by rejecting the heat to the cooling medium, which is normally air or water. Air gani, water gani, cooling medium ga use chesi lopala poye flow ayye refrigerant ni cool chesi condense chestundi, ante liquid form loki techestundi condenser lo. Then receiver, simply it is a storage device. The condensed liquid, the liquid coming from the condenser is stored in a vessel known as receiver, from where it is supplied to the evaporator through expansion valve or refrigerant control valve ద్వారా evaporator ki ee receiver pass chestu untundi. Okay, this receiver is placed between expansion valve and condenser. Expansion valve function is, it is also termed as throttle valve or refrigerant control valve. It has 3 names. Having 3 names: expansion valve or throttle valve or refrigerant control valve. It is used to allow the liquid refrigerant under high pressure and temperature. That is, it is used to allow the liquid refrigerant under higher pressure and temperature. Expansion valve em chestundi, high pressure and temperature where that liquid refrigerant ni allow chestundi dan dwara. As the liquid refrigerant passes through the valve, the pressure and temperatures are reduced. Whenever the expansion takes place in the expansion valve, the pressure and temperatures are reduced. Some of the liquid refrigerant evaporates as it passing through then valve due to friction. Through this is the passing through the valve due to friction. Due to friction between the liquid and valve, some of the liquid refrigerant will be evaporates. That's why the condition of the refrigerant after expansion valve is wet vapor. That is, the liquid and vapor mixture is called the wet vapor. Then evaporator is the another device. It is also a coil of pipe. Evaporator is also coil of pipe as that of the condenser, in which the wet refrigerant, what is the refrigerant which is from the expansion valve, that will be enter into the evaporator at low pressure and temperatures, is evaporated and converted into completely into vapors. Remaining liquid particles also, by absorbing the heat from the required space, completely the refrigerant will be converted into the vapor. So at the condition 1, the refrigerant condition is vapor after the evaporator, completely into vapors by absorbing its latent heat from the substance to be cooled. ఏ సబ్స్టెన్స్ అయితే కూల్ చేయాలో అక్కడ నుండి హీట్ అబ్జార్బ్ చేసుకొని కంప్లీట్ గా వేపరైజ్ అయ్యి that vapor again sent to the compressor. This is the compressor, reciprocating compressor, to which the work is given to the system, okay, WC. And this is the condenser at which the heat is rejected to the atmosphere. Okay, this is represented as QH. And expansion valve. In the expansion valve, there is no heat and work transfer taking place. Only the pressure will be reduced in the expansion valve. It is also throttle valve. The constant enthalpy దగ్గర ఇది జరుగుతుంది. దానివల్లనే దీన్ని ఐసెంటాల్పిక్ ప్రాసెస్ అంటాం. Enthalpy remains constant from 3 to 4. So isentropic process takes place in the expansion valve. Clear? Only due to the friction between the expansion valve and liquid, the pressure drop will be takes place. As we know that pressure drops due to friction is the major loss. That concept will be occurs in the expansion valve. So after the expansion valve, the wet vapor is sent to the evaporator. After expansion, the condition of refrigerant is wet vapor, which is having low pressure and temperature. The low temperature refrigerant will be sent to the evaporator, at which the heat is absorbed from the required place to be refrigerated. ఏ స్పేస్ అయితే రిఫ్రిజిరేట్ చేయాలో, ఏ స్పేస్ అయితే కూల్ చేయాలో, ఆ స్పేస్ నుండి హీట్ ని అబ్జార్బ్ చేసుకుంటుంది. దట్ ఈస్ రిప్రజెంటెడ్ యాజ్ QL. Okay, at low temperature, high temperature. Clear? This is the cycle. 1-2 is the reversible adiabatic compression. This is a 1-2 occurs in the compressor. This compression process will be reversible adiabatic compression or isentropic compression. Clear? 2-3 occurs in the condenser coil. Condenser coil is constant pressure heat rejection process. 3-4 is the throttling. 3-4 is the throttling isenthalpic process. This is the 3-4 isenthalpic process, constant enthalpy process during the expansion. And 4-1 is the constant pressure heat addition into the system. Constant pressure heat addition into the system from the required space. Clear? These are the 4 processes occurs in the simple VCR cycle. This is the representation of VCR system on TS and pH diagram. Here the pH diagram is very important when compared to the PV diagram. Here pH diagram like this and the TS diagram is like this. Let us look the TS and pH diagram for the 4 processes. 1-2. What is the 1-2? 1-2 is the process occurs in the compression process. It is called the reversible adiabatic compression. Reversible adiabatic compression means isentropic compression. Isentropic process will be represented on TS diagram vertically. And pH diagram, a curved line. In pH diagram, the isentropic process will be represented as a work. This is the curved line. 1-2 is the isentropic process. During this process, work is consuming by the cycle. WC is the work consuming by the cycle or work given to the compressor during this process. Okay. After compressing the refrigerant, which is in the superheated vapor form. Okay. In TS diagram, this is the liquid line. This is the vapor line. This is the vapor line. This is the liquid line. Already you have studied the TS diagram for the Rankine cycle. This is the liquid line, dry saturated liquid line it is called. This is the critical point of the refrigerant. This is the critical point of the refrigerant. From the critical point, the right side curve is the dry saturated vapor line or vapor curve. Beyond this dry saturated vapor curve, the painanta superheated vapor. Superheated vapor is the refrigerant. Refrigerant is in the form of superheated condition. Okay, and in between these 2 curves is called the wet region. wet region, in which some of the liquid refrigerant and vapor refrigerant mixture will be there. Okay, mixture will be present here in between these two curves. And below this curve, or left side of this dry saturated liquid line is called the subcooled liquid. Okay, subcooled liquid, the temperature of the liquid which will be less than the saturation temperature on the left side of the saturation liquid line. Okay, this is the superheated region. This is the dry saturated vapor line. This dry saturated liquid line. This is the wet region. This is the subcooled region. This is the critical point. Beyond that, the vapor and liquid are equilibrium. Vapor and liquid are in equilibrium. Clear that? This is the same pH diagram. pH diagram is like this from this saturation liquid line, saturation vapor line. So this is the superheated vapor region. This is the superheated vapor region. This is the wet region. This is the liquid region. So coming to the processes, 1 to 2 is the isentropic process, vertical line on TS diagram, curved line on pH diagram. Okay. 2 is in the superheated region. After compressing the refrigerant in the compressor, the refrigerant condition will be went to the superheated region. Okay. After the compressor, the refrigerant will enter into the condensing coil. The next device is condenser. From 2 to 3 is the condensation or cooling and condensation. From first few coils, in the first few coils, the superheated vapor comes to the dry saturated vapor by decreasing its temperature, and also reject the heat at this place. During this process, by this is decreasing decreasing the temperature. During this decrease in temperature, the heat will be rejected to the atmosphere. Okay, this heat rejected to the atmosphere is called the sensible heat. Clear? Due to this rejection of sensible heat, its temperature decreases from 2 to this point, dry saturated vapor condition. Okay. After that, by rejecting the some amount of heat, latent heat, this dry saturated vapor will be converted into the dry saturated liquid. So total amount of heat rejected from 2 to 3 is QH. This QH involves some amount of sensible heat, some amount of latent heat. During this latent heat rejection, the phase change occurs at constant temperature. Okay. Total 2 to 3 is the cooling and condensation occurs in the condenser coil. Clear? Then 3 to 4. This is a constant pressure line on TS diagram. Here constant pressure line is an horizontal line. Wherever the condition, it is in wet region or superheated region, it is represented horizontal line, constant pressure line. But in this TS diagram, constant pressure line is coincide with the constant temperature line in the wet region, and also the constant pressure line is inclined line in the superheated region. In the superheated region, the constant pressure line is an inclined line, and in the wet region, constant pressure line will be coincide with the constant temperature lines. That's why here horizontal line and inclined line. But in this pH diagram, the constant pressure line is a horizontal line independent of region. Whatever the region in which if it is a superheated region or wet region, whatever the region, the constant pressure lines are horizontal lines. Okay, 2 to 3 is what is 2 to 3? Condensation process by rejecting the heat QH to the atmosphere. Okay. Then 3 to 4, after condenser, the device is expansion valve or throttle valve, in which the isenthalpic process will be takes place. 3 to 4 is the isenthalpic process. It is an irreversible process. That's why it is represented by dotted line. Isenthalpic process in the expansion valve is an irreversible process, or it is a throttling process. Throttling process is an irreversible process. Already you learned in the thermodynamics. That's why it is represented by dotted line. 3 to 4 is the isenthalpic line. It is an inclined dotted line. In pH diagram, the 3 to 4 represented by a vertical line. Clear? Because it is a H3 equal to H4. That is the enthalpy remains same during that process. Vertical line. Isenthalpic process. Observe this process 3 to 4. Before entering into the expansion valve, the condition of refrigerant is dry saturated liquid. On this line, dry saturated liquid. After leaving the expansion wall, the condition of refrigerant is wet region. This is the wet region in between these two lines, wet region. So some amount of liquid particles containing a tree will be evaporates and comes into the condition of wet region after expansion wall. This occurs due to friction between liquid particles which is flowing into the expansion wall and walls of the expansion wall. Clear? రెండింటి మధ్యలో ఫ్రిక్షన్ డెవలప్ అవ్వడం ఎక్స్పాన్షన్ వాల్ వాల్స్ కి మధ్యలో లిక్విడ్ కి మధ్యలో ఫ్రిక్షన్ డెవలప్ అవ్వడం వల్ల ప్రెషర్ డ్రాప్ తో పాటు సమ్ అమౌంట్ ఆఫ్ లిక్విడ్ పార్టికల్స్ అనేది ఎవాపరేట్ అవుతాయి. ఎవాపరేట్ అవ్వడం వల్ల ద కండిషన్ ఆఫ్ రిఫ్రిజిరెంట్ అట్ ఎగ్జిట్ ఆఫ్ ఎక్స్పాన్షన్ వాల్ వెట్ రీజన్ లోకి వస్తుంది. అంటే కొంత అమౌంట్ ఇక్కడ లిక్విడ్ ఉంటుంది, కొంత అమౌంట్ వేపర్ పార్ట్ ఉంటుంది. But vapor part does not absorb the heat in the evaporator. In further process, vapor having no use, but liquid absorb the heat in the evaporator. Liquid only the required refrigerant state to absorb the heat in the evaporator. So, for 3 to 4 is the expansion process, isentropic process in the expansion wall or total wall. Coming to the 4 to 1. What is the 4 to 1? This is a 4 to 1 occurs in the evaporator. 4 to 1 occurs in the evaporator in which at constant temperature and pressure, the heat is absorbing. At constant pressure, heat absorbed from the required space. This is called the refrigeration effect here. QL is the refrigeration effect. 4 to 1 is by absorbing the heat from the required space, that is a QL, the liquid particles remains in the wet state, will be absorb the heat, and by absorbing the heat, the liquid particles will be vaporizes and completely converted into the dry saturated vapor state. After the evaporator, the condition of the refrigerant is dry saturated vapor state. It is a constant horizontal line in TS diagram within the within the dome. This is the wet region. Okay, a constant pressure line. This is that occurs constant pressure. That's why it is also horizontal line here. 4 to 1 at constant pressure, heat absorption takes place. Clear? Again, the refrigerant will be entered into the compressor. The cycle will be repeats like this. This is the TS and pH diagram. These two diagrams are very important for the VCR cycle, vapor compression refrigeration cycle. Okay, this is also called the reversed Rankine cycle. It is a phase change cycle. So, what are the interactions, work and energy? What are the energy interactions are there? During 1 to 2 work interaction, that is the work given to the system, it is a -1, negative work. And QH is rejecting to the atmosphere, it is also taken as negative. And QL is the heat absorbed by the system, QL. QL is the heat absorbed by the system. These are the heat interactions. This is the work interaction. During this process, there is no heat and work interaction due to it is an irreversible process. Okay. Analysis of cycle. Let us go for the work and heat formulas. WC, first one is WC, that is the work given to the compressor, is equal to, that is the, during this process, by applying the energy balance equation, that is the steady flow energy equation to this process, 1 to 2, we will get the WC is equal to change in enthalpy across the compressor, H2 minus H1. Okay, this is the, that is the steady flow energy equation will be represented like this. A steady flow energy, what is the steady flow energy equation? That is steady flow in steady flow energy equation, H1, that is at 0.1. We are applying the energy at 0.1. Total energy at 0.1 is equal to total energy at 0.2 during the flowing. H1 plus W, work done during the work given to that process, WC, H1 plus WC, that is equal to H2 plus, is there any heat interaction? That is the QC or QC. Here QC, what is the heat interaction during this process? This is isentropic process. Due to isentropic process, this Q is 0. Okay, like this, you have to apply the energy balance equation between 1 and 2. Energy remains same during the process. So energy before entering into the compressor is equal to the energy after entering into the compressor. From this, WC equal to, we can write as H2 minus H1. That is in terms of enthalpy difference. Okay, to find the WC, we have to write the H2 minus H1 is the formula. Then coming to the QH, during this process 2 to 3. What is 2 to 3 process? Is a cooling and condensation process by rejecting the heat QH. The superheated vapor is converted into the dry saturated liquid in this case. Okay, QH is a Q rejected is equal to H2 minus H3. Here also we can write the formula in terms of enthalpies. That is the H2 here, H3 here. Here the work transfer is no work transfer will be take place, only heat transfer. Therefore, H2 plus W is equal to H3. Okay, plus Q, that is QH here. But QH is rejecting the heat. This is taken as negative. Okay. So no work transfer will be taking place during the process 2-3. Therefore, QH is equal to H3 minus H2 or H2 minus H3. We can write which one is the more. That H2 is the more highest one than the H3. That's why we are taking the amount of heat rejected is positive. That is the amount of heat rejected is the value we want. That is amount of heat rejected is H2 minus H3. Okay. Then H3 equal to H4. During this process, the enthalpy remains constant. H3 equal to H4. The H3 equal to H4, which is represented in a TS diagram, a curved dotted line, but in a pH diagram, it is a vertical dotted line. That is the H3 equal to H4 at this place. Isentropic process. It is also called the isentropic process. And QL, or heat absorbed by the cycle from the required space, that is the Q heat added is equal to amount of, that is the enthalpy after the heat adding minus enthalpy before the heat adding, H1 minus H4 or H1 minus H3, because H4 is equal to H3. You can write H1 minus H3 or HF3. HF3 in some book, HF3 is also represented. HF3 means at this point, fluid enthalpy or H3, directly we can write as H3. So therefore, refrigeration effect is the amount of heat absorbed in the evaporator. This is the refrigeration effect, heat absorbed in the evaporator per kg. Then we will get the COP. Performance of the cycle can be like this. Heat absorbed in the evaporator, that is the refrigeration effect, divided by work supplied or work given to the compressor. So QL is H1 minus H3 divided by work given to the compressor is, in terms of enthalpy, H2 minus H1. Here, we should know the enthalpies of each point of the cycle. Then we can find the heat absorbed, heat rejected, work done, and COP. These are the formulas. Okay. The total, every formula will be represented in terms of enthalpy here, because it is a phase change cycle. We should not write in MCP delta T, because whenever this MCP delta T will be used, this MCP delta T represents only sensible heat. Okay, whenever the temperature changes from one place to one point to another point, then to calculate the heat transfer rate, we can use MCP delta T. This is only for sensible heat. This is this formula used in the air refrigeration system for every process to calculate the temperature at each point. MCP delta T we are using without any phase change. But if phase change occurs in the cycle, we does not use MCP delta T. Only you can substitute in terms of enthalpy change. Okay. This is the analysis of vapor compression cycle, in which the four process simple vapor compression. This is called the simple vapor compression cycle. In simple vapor compression cycle, the initially before the compressor, the dry saturated vapor condition. From that, it is compressed to the superheated vapor. From there, the refrigerant will be condensed to the dry saturated liquid. From there, it is expanded in the throttle valve to the wet vapor. And from that 4 point, the evaporator will be converted to the dry saturated vapor again. Again, the refrigerant will be entered, vapor refrigerant will be entered into the compressor. This is the simple vapor compression cycle. In this cycle, we are going to study in different conditions. That is, before compression is if the before compression is wet region, what happened? If the before compression is superheated region, what happened? How to calculate the enthalpies? And before after compression, if it is the after compression is in wet region, then how to calculate the enthalpy? Okay, these are the different types of cycle we are going to study in the further further topics. These are the types of cycles I explained here. Already explained, that is what are the types of cycles. Types of vapor compression cycles are these, that generally we are subject to point of view. These 5 cycles are going to study. Okay, in these 5 cycles, cycle with dry saturated vapor after compression. Cycle with dry saturated vapor after compression. That is, compression tarvata, the condition of refrigerant must be dry saturated condition. Okay, like this. And cycle with wet vapor after compression. After compression, the condition 2 is in wet vapor. That is one type of cycle. And cycle with superheated vapor after compression. This is a simple vapor compression cycle. As earlier I said, this is the cycle with superheated vapor after compression. This is the compression process. After compression, the condition of the refrigerant is in superheated region. Okay. Cycle with superheated vapor before compression. 1 point is in superheated region. If 1 point is in superheated region, the cycle is like this. This is the horizontal line, and this is the inclined line. Constant pressure line is inclined line. From this 1 point, it is compressed, vertical line, like this. If the state of the refrigerant before compression is in superheated region, the cycle is like this. 4, 1, this is represented 1 dash, and 1, 2, 2 dash, 3, 3, 4. This is the cycle when the superheated condition is there before compression. Okay. Then last cycle is cycle with undercooling or subcooling of refrigerant. Subcooling process. Subcooling means the cooling of the refrigerant below its saturation temperature. Whenever we reduce the temperature of the refrigerant below its saturation temperature, that refrigerant is called the subcooled liquid. Okay, which occurs on the left side of the, which represents on the TS diagram on the left side of the saturation liquid line. Whenever we represent the refrigerant state, left side of this line, that refrigerant is called the subcooled liquid. Okay, this is the cycle with undercooling or subcooled. One by one, we will explain. I will explain the 1 by 1 cycle, and after explanation, I will solve the problems for each case. Okay. Let us go for the first type of cycle in this class. Cycle with dry saturated vapor after compression. This is the cycle with dry saturated vapor after compression. Theoretical vapor compression cycle with dry saturated vapor after compression. Dry saturated vapor means the vapor is on dry saturated vapor line. Vapor condition, the state of the refrigerant is on dry saturated vapor line. Okay. This is the TS diagram. This is the pH diagram. Let us go for the first TS diagram. During the compression process, after compression, the state of the refrigerant is on the dry saturated vapor line. Okay. Whenever the second condition is a dry saturated vapor line, automatically the before compression, it must be in wet region. Okay. Then only after compression, the state of the refrigerant is dry saturated vapor is possible. Okay, after the dry saturated vapor compression, that will be entered into the condenser. In the condenser, that dry saturated vapor is converted into the dry saturated liquid by rejecting the heat during this process, latent heat. By rejecting the latent heat, the condition 2 is changes to condition 3. It is occurs at constant temperature, T2 equal to T3. After that, 3 to 4 is the isentropic process, expansion process in the throttle valve, during which the dry saturated liquid is converted into the vapor line due to friction. From there, from the fourth state, the refrigerant will be entered into the evaporator, in which at constant temperature and pressure, T1 equal to T4, at a constant temperature and pressure, by absorbing the heat, latent heat, the liquid particles is converted to, some of the liquid particles is converted to the vapor part. Even though after evaporation, the wet region is, the condition of refrigerant is wet region itself. So some more amount of liquid particles are there at point 1. These liquid particles having a nature to absorb some amount of heat to convert it into the vapor. But at this condition only we are compressing. This compression process is called the wet compression. Okay, because we are compressing the wet vapor. Wet vapor refrigerant we are compressing. That's why it's a wet compression. At point 1, some amount of liquid particles will be present. Due to that liquid particles, the corrosion occurs in the compressor. That's why the compressor will be damaged whenever we compress the wet vapor. Okay, this is the one of the disadvantage by this cycle. The same cycle will be represented on pH diagram, in which one is in wet region, which is compressed isentropically. It is a curved line on the pH diagram up to dry saturated vapor point. This is the 2 is on the dry saturated vapor line. These the red lines are dry saturated vapor 1, and another one is dry saturated liquid line. From that dry saturated vapor, by rejecting the heat to the atmosphere or air or water, it will be converted into the dry saturated liquid. Okay, here the heat is rejected to the cooling medium, which is generally air or water. This is the condensation process. This is called the condensation. When vapor is converted to the liquid, it is called the condensation at constant pressure and temperature. Clear? After converting the dry saturated liquid in the condenser coil, it will be expanded. Isentropic expansion process, constant enthalpy. HF3 equal to H4. It is also called H3 or HF3, fluid enthalpy. Is the liquid line itself. On the liquid line, we can represent HF. Okay, HF3 or H4, both are equal here. From there, the refrigerant wet region, wet vapor refrigerant will be entered into the evaporator, in which some amount of heat absorbing by the from the required space. By absorbing the latent heat, some amount of liquid particles will be converted into the vapors. Even though after conversion of the evaporator, the condition 1, the refrigerant state is in wet region itself. Okay, this wet region refrigerant having some more amount of ability to absorb the heat. It is having some amount of heat. It can be absorb the heat from the required space, having the some ability, even though it is having liquid and vapor. Okay, the condition 1 is the wet region. From there itself, the compression process occurs. From the wet region itself, the compression process is occurring. To obtain the condition of refrigerant after compressor is dry saturated vapor. This is a cycle. Okay. In this, the disadvantage is we are compressing the wet vapor in the compressor. Due to this wet vapor, liquid particles containing it before the compressor may damage due to corrosion. Okay. And also it requires more amount of work to compress the liquid particles. So liquids are incompressible fluids. To compress the liquid particles, it consumes more amount of work. So work required is more for this cycle to compress the wet vapor. Okay, this is a process where I explained here. A vapor compression cycle with a dry saturated vapor at low pressure is shown in TS diagram. After compression is shown in TS diagram and pH diagrams, A and B respectively. At point 1, let T1, P1 and S1. S1 is the entropy at point 1, P1 is the pressure at 1 and temperature at 1. Be the temperature, pressure and entropy of the vapor refrigerant respectively. The 4 processes of the cycle are as follows. These are the 4 processes. First process is the compression process. The vapor refrigerant at low pressure P1 and temperature T1 is compressed isentropically to dry saturated vapor, as shown by the vertical line 1, 2 on TS diagram. This is the 1, 2 line vertical line compression process. And by the curved line 1, 2 on the pH diagram. The pressure and temperature rises from P1 to P2 and T1 to T2 respectively. Temperature and pressure rises due to compression process. The work done during the isentropic compression per kg of refrigerant is given as W equal to H2 minus H1. H2, H1 are enthalpies after and before compression. H2 are enthalpy per kg. Its units for enthalpy is kilojoules per kg. These are the property of refrigerants. Okay, enthalpy of the refrigerant after compression and enthalpy of the refrigerant before compression. Enthalpy of vapor refrigerant at T1, that is at suction of the compressor. Enthalpy of vapor refrigerant at T2, that is at discharge of the compressor. This is totally compression process. After compression process, and then condensation process. This is the condensing process. The high pressure and temperature after compressing vapor refrigerant from the compressor is passing to the condenser, where it is completely condensed at constant pressure and temperatures at P2 and T2. It occurs at constant temperature and pressure, completely converted to the liquid state by rejecting the latent heat. The vapor refrigerant is changed into liquid refrigerant here. The refrigerant, while passing to the condenser, gives its latent heat to the surrounding condensing medium. This condensing medium is air or water generally used. In domestic refrigerator, the condensing medium is air. In the cold storage, that is the high capacity plants, we are using water as a cooling medium to absorb the heat from the refrigerant passing to the condenser. Okay, then expansion process. Expansion process occurs in the throttle valve or expansion valve, which is also called refrigerant control valve. The liquid refrigerant at pressure P3 or P2. This is the P3 or P2, both are same. At this condition, liquid refrigerant will be entered into the throttle valve, expanded by the throttling process. This throttling process is the irreversible process through the expansion valve to a low pressure P4 or P1, both are equal. After expansion, the pressure is P4 or P1, both are equal here. And the temperature T4, that is also equal to T1. Temperature is also same as shown in the curve 3,4 on TS diagram. And by the vertical line 3,4 on the pH diagram. This is the vertical line on the pH diagram 3,4. Isentropic process. Enthalpy remains constant. This is a curved line on TS diagram. We have already discussed that some of the liquid refrigerant evaporates. Konta evaporate avutundi friction valla in the expansion valve as it passing through the expansion valve. But the greater portion is vaporized in the evaporator. Ekko matram evaporator lo vaporize avutundi. We know that during the throttling process, no heat absorbed or rejected by the liquid refrigerant. So in throttling process, heat gani work gani transfer kavu. Only expansion process occurs due to friction. Okay, due to expansion process, due to friction, some liquid particle will be vaporized. Some part of the liquid will be vaporized, but major part of the liquid will be vaporized in the evaporator itself. Last is vaporizing process, the evaporator, which occurs in the evaporator, evaporation process. The liquid vapor mixture of the refrigerant at P4, pressure P4 or P1, and temperature T4 or T1 is evaporated and changed into vapor refrigerant at a constant pressure and temperature, as shown by the horizontal line 4.1 and pH diagrams, TS and pH diagrams. During the evaporation, the liquid vapor refrigerant absorbs. Liquid vapor refrigerant means wet vapor. The mixture of liquid and vapor refrigerant absorbs its latent heat of the vaporization from the medium, air or water or brine solution. Whatever the space which are be cooled from there, it is absorbed by absorbing the latent heat, it vaporizes in the evaporator, which is to be cooled. Air or water or brine solution. These are the secondary refrigerants which are used in the vapor compression cycle. This heat which is absorbed by the refrigerant is called refrigerating effect. ఏదైతే మనం ఎవాపరేటర్ లో అబ్జార్బ్ చేస్తున్నామో, ఎవాపరేటర్ దగ్గర అబ్జార్బ్ చేస్తున్నామో ఆ హీట్ ని మనం రిఫ్రిజరేషన్ ఎఫెక్ట్ అంటాం ఆర్ కూలింగ్ ఎఫెక్ట్. అండ్ ఇట్ ఈస్ బ్రీఫ్లీ రిటన్ యాజ్ RE. The process of vaporization continues up to point 1, which is at the starting point, and thus the cycle is completed. Okay, we know that the refrigeration effect or heat absorbed or heat extracted by the liquid vapor refrigerant during the expansion per kg of refrigerant is given by RE, evaporation. During the evaporation, RE equal to change in enthalpy across the evaporator, that is H1 minus H4. During this process, how much amount of heat absorbed? That is change in enthalpy. H1 minus H4 is the amount of heat absorbed by the refrigerant per kg. H4 can be also written as HF3 because H4 equal to H3 or H3 is also written as HF3. Is that therefore HF3 equal to H4. Where HF3 is the sensible heat at temperature T3, that is enthalpy of liquid refrigerant leaving the condenser. It may be noticed from the cycle that the liquid vapor refrigerant has extracted heat during the evaporation. The work will be done by the compressor for isentropic compression of this high pressure and temperature vapor refrigerant. Therefore, coefficient of performance, COP of the cycle is refrigeration effect, that is H1 minus H4 or H1 minus HF3 divided by work done during the compression process, that is H2 minus H1. This is the formula to calculate the COP. But H1, HF3, H2, H1 are properties, enthalpy of refrigerant at different conditions. The ratio of COP of vapor compression cycle, this is the vapor compression cycle COP, to the COP of Carnot cycle is known as refrigeration efficiency or performance index. Ratio between the COP performance of VCR and COP of Carnot called the efficiency, refrigeration efficiency. COP of vapor compression cycle is always less than the COP of Carnot cycle. It is less than 1. The ratio between these two is less than 1. That is called the refrigeration efficiency or performance index. Okay. These are the worked examples on the first type of cycle. That is the cycle with dry saturated vapor after compression. Okay. This is the first cycle I explained. Remaining cycle I will cover in the next class along with their problems. Okay. I am closing this class today. Okay. Bye. Have a nice day.